So to commence this boiler build, then I'm going to start with this smoke box tube plate that wants making in 3mm copper. On the drawing it says you can either use 1/8 of an inch copper or 3mm copper, but the 1/8 of an inch copper is a very rare commodity these days, so it would normally be used in 3mm in this particular size of boiler that we're making. What I need to make to form this is what's called a former, and that former will simply be a round disc of steel with a wood backer on it, which again will be just sewn to a round disc and turned up in the lathe, such that we can fit the round disc that we've made onto a piece of flat copper, and we will get the flat copper. We will mark around the former, and then we will cut that piece of copper out into a round shape. We will lay what we have made, which will be the former, on top of that and in the centre, and then we will simply get the former on top of the copper. We will warm the copper up and we will literally bend the copper over, forming this flange here. That's what we aim to do. So we need to know what size of disc we need to make to fit inside this tube plate when it's complete. We start that by measuring the boiler. So we will measure the boiler's internal diameter just to ensure that it's A, the diameter that we actually want, and B, that if we were to rotate that round, it is actually round rather than being some kind of an oval shape that's been knocked well out of shape by some reasoning or other. So we need to ensure that this is fairly circular in diameter. We need then to make our copper tube plate to fit inside that boiler barrel like that, with about a 3/1000th of an inch gap all the way around. So we would have 3/1000th of an inch on this side and 3/1000th of an inch on that side. So this would eventually just be some kind of a sliding fit inside the boiler barrel itself. So knowing that we're going to make this piece here from 3mm copper, we need to measure the internal diameter of our boiler barrel with a set of calipers that are suitable for the job. The bigger the boiler barrel, the bigger the calipers you would need, or vernier gauge should I say. So we would measure internal diameter of the boiler barrel. That would then give us the external diameter of this plate that we would need to make this tube plate. So what we would then need to do is deduct from this diameter that we've now got, we would need to reduce 3mm from this side of the circle and 3mm from this side of the circle. So our former to make this tube plate would be, in actual fact, 6mm less than the boiler barrel itself. So let's crack on then and make the steel former that we're talking about to make this tube plate. I got my copper material from Fred at Craft Metals, which I found to be very good quality at the time. Pricing. So the first thing we need to do is, with these vernier gauges, make sure that this is somewhere near round for circumference all the way, and if it's not, then we'd have to tap it and squeeze it once it was softened after annealing, such that it fitted onto the disc that we're going to fit inside there. But to measure this correctly internally, we need to file off any burrs that may have been there during the cutting of this. So I'll just go around and clean off the burrs inside and any burrs on the outside. I will clean them with a file. And what we also need to do is to make sure that when it was cut square across, so we can file and make adjustments, or perhaps put this diameter in a lathe and turn it and face it off if it's wildly out of what we actually want. But that would be the thing to do, and try and ensure that this is a square face to start with, and make sure that we know the internal diameter of it and that it is actually circular and not egg-shaped, if you like. So I've set this copper barrel up in the bench vise with a cloth in there to keep it from scratching, hopefully, and it's fairly sturdy. I'm not tightening it up too much, and I have got jaws in like that underneath, such that there's no raggedness up against this face of the copper. And I've been filing the end of both ends of this tube as best I can. This one I haven't bothered too much with getting it straight, because this end needs shortening back yet in any event, but this is the end where I'm going to put the boiler tube plate, the round one that we've been looking at initially. This end I've tried to get this fairly squared up with the square, because this one matters to a greater extent, because at this end of the boiler, which will be the cab end of the locomotive, I need to get a piece of oblong copper like that, a flat plate, and form it into that kind of shape for over the firebox end of the boiler. So in saying that, I want this joint here to be as good as possible. So I've set this up on the milling machine, and I've got on the milling machine table, sorry, and I've got a 10 thou rock across that face. I think the 10 thou rock will be quite acceptable. So that's what needs to happen there. And I've just set this thing up and filed it round, and then I've finished it off. There's the file, round file inside the edges there, like that, and squaring across like this, etc. And I've marked up, you can probably see reference marks here where most of the filing needed to be done on this section here to bring it somewhere near to square and level. But it needs bringing back in length, in that I did order it slightly over the nominal length that I wanted, because I wasn't sure how cleanly cut the ends were going to come. So I wanted it such that I could always bring it back and square these ends up myself. So that's what I've done. So the next phase I'm going to do now, I'm going to make the former for in here that the plate will be formed over, that will form the tube plate, and that goes at this end, but I'm just showing you this end because you can see it. So basically I'm going to now make a round disc that fits inside here, because I've been trying to measure this with vernier calipers, vernier gauge, and each time you do measure you get ever so slightly different, and it is hard trying to find out just where you are directly across the middle of this, but it is somewhere near very round. It may have been a lot less round than this had I formed it myself on a bending rolls, etc., which some people may do, and then they might joint it. But this is a purchased seamless tube, so we would assume that it is somewhere near round, which it is, fairly perfect according to my gauge here. But what I want to do, I'm going to make a steel round plate that will just be a nice sliding fit in there, and once I've got that sliding fit inside here, then I'll be able to machine it down in the lathe to exactly the dimension to allow for the thickness of the walls of the tube plate when I've formed that tube plate. But you'll see what I mean as we go through the video. So we can see this is the setup of the copper tube sat on this bed of this milling machine which I've got, and I've been squaring it up with the square, trying it in different locations thus, and turning the tube round on this flatbed here. And what I've managed to do is get it to within a 10 thou rock, so I can just get a 10 thou feeler gauge under the worst offending area. And I've been looking with a torch through the gap to try and ensure that the gap all along here is the same, etc. So that's how I've been squaring this up, and then taking it back to the bench vise and doing more filing and more modifications to it. So once it was filed, I then just ran some emery cloth followed by wire wool around the edge to get rid of any burrs so that I could measure it all the better. So I've come across to the lathe now, and I've found this suitable piece of steel, as I might call it, and I've written on it the 3 jaw numbers of this chuck, and I've also written the jaw numbers on the chuck itself for reference points. And the plan is that this piece is going to be put in with the number 1 against number 1 jaw there, and it will be set 3 dimples back on this chuck and tightened in. Show you the 3 dimples in a moment, or 3 sections should I say. So that will be tightened up like that. So here are the 3 points of contact, 1, 2, 3 that I was talking about, and then these points of contact will give this a fairly good sense of trueness when it's spinning. And the idea of this then is that I'm going to make a steel plate slightly bigger in diameter than this, and this will be attached to the front face of here. So what I need to do first, because I'm going to put this and machine this, I need to make sure that this face here is truly square with the lathe bed. So hence these are the numbers, etc., so that this will always go back into its relative position. So a piece of plate like that will be fastened onto the front of there. I'll then be able to machine this edge down to be a nice snug fit inside the boiler barrel that we've been looking at, and once I've done that, I'll be able to further machine this down by the thickness of the material that we're going to form the plate from. And this steel plate will then be used to put the copper against, and the copper will then be bent over this edge here, forming the flange of that particular copper plate that we're making. I'll put a radius on the front end of this steel here, so that this edge of the steel doesn't damage the copper and form too steep a right angle. This wants to be a nice radius edge. And then what I will do, I will drill a hole in some material like this, which is a very close grained plywood, and that will go behind the steel plate to make this edge of the plate, if you like, thicker, such that we can form the copper over this plate when it's that thickness. So that will go there, that will go behind, and the whole thing will be trued up in the lathe with this drilled and bolted onto the front face of that, which I'm just going to face down now so that it's running 90 degrees to this lathe bed. So I'll just give that a safety spin, make sure it's locked in. You just get them so they're lined up, the numbers lined up with the jaws. Give that a safety spin to make sure nothing's going to hit, and then we can bring this piece across, bring the tool in until it just touches the face of the material. Then we bring the tool out, it's just touching now, so I'll bring the tool out, lock the saddle in position so that it's not going to go back when I send the tool across. Make sure everything's tight. Final spin, make sure everything's okay there. So there's just a little bit left here that the tool hasn't touched yet to square this face off. So I'll just move the tool a little nearer to the job. Lock the saddle again, and then we'll take a facing cut a second time. Safety twist. So there we are, that's squared across now with the lathe bed. So I'll just knock the burr off the end of there now to make it less sharp to the touch. Safety twist again. Lot better. I'll deburr the inside of that now with the deburring tool. It's like a handheld blade type thing. Just pop that in there and go around. So there we are now. That's the deburring done inside and outside, and squared across. So now this can be drilled and tapped, etc., to secure the steel plate, and then I can make the steel plate the diameter that I want.